Hello guys, and welcome back to Tronics Energy. So last time we'll say that we're going to start looking on fun things that you can use, or fun things that you can make using the NE555A stable mode oscillator. And today we are going to connect. Today we have connected an NE555 to a CD4017, which is a decade counter. So the decade counter has 10 outputs, and those 10 outputs have connected to 10 LEDs. They are of different colors. We have blue, then green, then yellow. Yeah, yes. So once there's a clock signal, or once the clock signal is connected to pin number 14 of the IC CD4017, then every rising edge of the clock will move the bit from the previous bit to the next bit. So if it start at pin A, then it's going to move to 2, 3, 4, 5, 6, and once it gets to the 10th output, it goes back to the first output, and that sequence continues on and on and off. That's the function of the CD4017. So this circuit, you can just use this to make maybe an LED chaser, or all those fun projects that you have in mind. If you notice in our first circuit right here, which is NE555 in A stable mode, there's actually some new circuitry that I've added. I've added a potentiometer just to vary the speed of the output of the NE555, or the frequency. I've also added a 0.01 microfarad capacitor from microfarad ceramic capacitor from pin number 5 to ground, just for stabilization. And also there's a 0.1 microfarad ceramic capacitor across the voltage source to ground. So these all are just for the stabilization. Why am I doing all this? Because I want to try and generate one has, if you can see, one has output, one has frequency output. The function of this, because I want to make a clock, and that's the new series that we are going to do. I want to make a clock, and I want it to be precise as possible. So the seconds should be in one has range. And for me to get that, I've added this as two capacitors just for stabilization. There's also a 10K resistor across from the output of the clock to ground, also for stabilization. But all this can be changed. I can just use a crystal oscillator. Crystal oscillator normally used in clocks, it's about 32 point, I don't know what's from there, but this is one that is used to make the clock signals very accurate. We use the 32 point, I think it's 6 or 4 has crystal oscillator, plus we add a CD4060. Now from this point is when we can go to CD4017, the decade counter. So this gives you a more accurate seconds counter than this one, but because I don't have it for now, I'm just going to use the NE555. But next week I'm going to have these two, the crystal oscillator and the CD4060, just to get the more accurate seconds generator. Now from there, at that point, I'm going to add another CD4017 to be counting the minutes and all those, and from there we can continue building the circuits slowly by slowly. So yeah, so if I can just turn this on, you can see every rising edge makes the LED, the output, go to the next output one bit at a time. So that's the function. So right now I've set it to be maybe approximately 1 second, but I cannot get exact 1 second because this IC is very it's not the best option to use. So yeah, so this is a circuit, and we're going to build it from there. We're going to go on further, and I hope you understand, and I hope you get what we do. So thank you very much guys for watching. Please subscribe to Tronics Energy, and I hope to see you next time. Goodbye.